Welcome to Go Get It. Today we are going to see one of the most important job scheduling algorithm, that is round robin algorithm, which is designed for time sharing systems. Before we proceed further, make sure that you are well aware of some basic technologies like ReadyQ, FCFS, that is first come first serve algorithm, and Gantt chart. Round robin algorithm is similar to FCFS algorithm, but with preemption. A predefined time quantum is maintained for preemption. We'll consider an example to illustrate the working of round robin algorithm. The table here shows some set of processes submitted to the job queue at instance t equals to 0, and their respective burst times are mentioned here. So for process P1 the burst time is 6, so on for P2 is 5, and so on. Here we will assume a time quantum of 2 units. So it means that no processes is allocated the CPU for more than one time quantum, that is 2 units. If a process burst exceeds one time quantum, it will be preempted and put back in the ready queue. As you must be aware of Gantt chart, which is used to plot the processes in ready queue based on their burst time. You can see the Gantt chart here. Due to lack of space, we have divided the Gantt chart into two parts. Let us see now the working of round robin algorithm. The first process in the ready queue is P1 with a burst time of 6. As the predefined time quantum is 2 units, it will get preempted after 2 units of time. So let's allocate P1 the CPU. It will execute for 2 units of time and it will be remaining with 4 units of time, and it will get preempted and it will again put back into the ready queue. So the next process in the ready queue will be P2 and it will be allocated to the CPU with a burst time of 5. You can notice here it will execute for 2 units of time and it will be remaining with 3 units of time. Similar is the case with P3. P3 is having burst time of 2, which is equivalent to time quantum of 2 units. So it will get executed for 2 units of time and it will be removed from the ready queue as it has completed its execution. Next process being P4 with a burst time of 3 units. It will get executed for 2 units of time and it will be remaining with 1 unit of time. Mind well that all the processes which are getting executed are put back in the ready queue. So next upcoming process is P5 with a burst time of 7. It will get executed and it will be remaining with 5. Now the first process in the ready queue is P1 with a burst time of 4. Similar process will be followed here and it will be left with 2 burst times. Next is P2 with 3. It will left with 1. Next is P4. We can see here it is left with only 1 unit of burst time. So it will get executed only for 1 unit of time. So you can notice here it will get executed from 14 to 15. And it has completed its execution, so we will remove it from the ready queue. Next is P5 with burst time of 5 and it will be left with 3. Next is P1 with 2 and it will be removed as it was left with only 2 units of time and it will be removed from the ready queue. Next is P2 with a burst time of 1. So it will get executed for 1 unit of time, that is from 19 to 20, and after execution it will be removed from the ready queue. We are left with P5 with 3 units of time. As the given time quantum is 2 units, it will get executed for 2 units of time first. You can notice here it will get executed from 20 to 22 and it will be left with 1. And as there are no process in the ready queue except P5, so next process will be P5 with 1 unit of time, and that's it. All the processes from the ready queue has been removed. This way all the processes have been executed and we are left with 0 processes in the ready queue. Now our next target is to calculate the average waiting time. You can notice here for P1, as it has arrived at time 0 and being the first process in the ready queue, it will get executed initially with 0 waiting time. It will get executed for 2 units of time and it will be put back into the ready queue, and it will be keep waiting till its next chance. So we have calculated here 10 minus 2, that is shown here, as P1 is submitted at the 10th unit of time after get completed from 2nd unit of time. This way we will calculate all the average waiting time of processes, and we are finding that P1 is having waiting time of 13. Similar is the case with P2. And this way we have calculated all the waiting time of the processes. The average waiting time is calculated by taking average of all the processes waiting time. So here you can notice that 13, 15, 4, 12 and 16. All these additions are divided by number of processes, which is 5 here, and we are getting the average waiting time as 12. That's all, and we are done with round robin algorithm. Subscribe more for videos.